So now we're talking about the topological sorting. So this is the DAG. Direct. Direct means we have a direction. So, and this is the node cycle in the graph. So in degree is means that the number of edge coming to the vertex. This is coming to the vertex. This is called in degree. And out degree is coming out. So the degree of vertex, for example, the node 0, it has 0 in degree, but it has 3 out degree. So we don't have to see another example. So I use this algorithm, and it's just keep track of the in degree of each node. So the first step, we have to initialize the in degree as a hash map, and it all values as 0, and source is a cube, and we have an order array. An order array, this is our final answer. And step 2, we have to count the in degree of each node. And step 3, we will add nodes with 0 in degree. And step 4 is really important. We have to check the sources is not empty. If the sources is empty, we have to directly to the step 5. And step 6, step 4, 4a, we have to remove a node from the front of source because the sources is a cube. So we have to pop it from the front and add the node to the order. So we have to decrement the in degree by 1 for its neighbors, whose neighbor is just this one, the front of sources, the node. Just pop it. And if any neighbor has 0 in degree, we have to add it to the sources. So repeat the step 4 until the sources is empty. And the final step, we have to check the number of nodes is equal to the nodes in the graph. So we have to check, just I mentioned, the number of nodes in the order is equal to the number of nodes in the graph. So what if it is not equal? If it is not equal, we will find a cycle is detected in the graph. And the code implementation. So the time complexity will be O of V plus E. The V is vertex and the E is edge, and the space is vertex. And now we jump to the example. So now this is the example for the topological sort. So we have to prepare the in degree. This is a hash map and stores the current in degree of each node. And the sources is a queue. It contains the nodes with 0 in degree. And the order, this is an array and stores the node in topological sorting. And so our step 1 is to initialize our in degree hash map with all values 0. and the sources queue and the order array. And now we have to count the integrity of each node. And the step 3 is add nodes with 0 degree to sources. So now we have to initialize the integrity. We have to count the integrity of each node. And how to count? Like in this graph, we have to count how many integrity for this node. 0. No. So it's 0. And for 1, how many integrity goes to node 1? 1, just 1. So this is 1. And also for the 2 and 3, it has 2 integrity, so it is 2. And 4, we have 1, 2, 3, 4, so it goes to 4. So now we finish our integrity. So we have to add nodes with 0 integrity to sources. So who is the 0 integrity? 0, right? So sources 0. So we check the sources is not empty. And the 4a, remove a node from the front of the source and add the node to order. And b, decrement the integrity by 1 for all neighbors. So who is 0's neighbor? 2, 1, 4, right? So 2, 1, 4. So now we have a new integrity. So 0, 0, 0, 2, 3. So now whose integrity is 0? 1 and 2, right? So we add the neighbor to the sources. Then we check. The sources is not empty. And we remove a node from the front of the sources and add the node to the order. So now our current node is 1. And now we have to decrement the integrity by 1 for all neighbors, 1's neighbor. So the 1's neighbor is 4 and 3. So 4 and 3. So it becomes this. So whose integrity is 0? No one. So the sources is not empty. And we remove a node from the front of the sources and add a node to order. Then now we have to decrement the integrity by 1 for 2's neighbor. Now our current node is 2. So 2's neighbor is 4 and 3. So now the integrity 3 is 0. So we add the 3 to sources. So we check. The sources is not empty. So we remove a node from the sources and add it to the order. And now our current node is 3. So we check. Who is the neighbor of 3? So it's 4, right? So we decrement to 0. And who is the integrity 4 is 0, right? So we add it to the sources. And now the sources is not empty. And we remove it from the sources and add it to the order. And now
The current node is 4. So now the sources is empty, and the step 6 we have to check the number of nodes in order is equal to nodes in the graph. So the nodes in the graph, we have 5 nodes. In the order we also have 5 nodes. So now we have the final answer. The nodes in order equals to the number of nodes in the graph. It is the final answer is the topological sorting result.
So now we have to implement our topological sorting. So the first step, we have to build the graph. So the number of nodes and so the graph is so for the age A and B will be age, and we have to append to the graph. And because we have direction in this graph, so it means A to B. So after the loop, we will have the graph. So what is next? We have to find our order line. So the input is number of nodes and age. So first, build our graph for our build graph function. And then we build the graph. And then we have to initialize the integrity. The integrity is a hash map. So now we have to build our integrity. Like the first step is initialize, and next step is to find out the integrity. So the node and its neighbor. So for the neighbor, in its neighbor. So we will find in degree neighbor would will have to plus one. And now finish this loop, we will have a integrate hash map. And then now we have to build a sources. This is the queue. And so we have to pick the the integrate's value is 0, and we have to append to the sources. Okay, so the node and value increase items. So if value equals 0, and we have to append it. So the order will be our final answer. So while these sources are while the sources has element, we have to continue this loop. So our current node will be the top of the sources is the front of the sources. We have to make sure it's the front, so we have to pop that. So the order append this current node. So um so for neighborhood in brand current node. So in this step we have to decrease decrease the neighbors in degree. So in degree neighbor is one. So we have to check if the in degree of neighbor equals 0, we have to append it to the sources. So so if we left this loop, it means the sources has no is empty. So we have to check the last step. If the length of order equals to the number of nodes, we have the final answer. So if it is not equal, it means that we detect the circle. So we just return this empty string. So I think it will be a final answer. So we can get the answer to 0, 1, 2, 3, 4. It is our final answer.